Hello. In this video, we will discuss about body effect of NMOS transistor. What will happen if source voltage is not same as body voltage? Generally, what we did till now is both source and body is connected to same voltage, that is ground together. But in some cases, source voltage will be increasing but body voltage will be grounded. So in these cases, what changes we will observe? We will look at this. So this MOSFET diagram we can see as follows. This is metal region and this is oxide, and this we will have semiconductor region. So when we will apply gate voltage, channel gets formed and depletion region will be also there. So these are drain voltage VDD, and here it is source to bulk voltage. Here generally, here I have grounded the bulk voltage. Now here source voltage will be changing. Uh, in general cases, what we did is source and bulk both were grounded together. In that cases, there would be no bulk effect. But when source is floating, that is source voltage is more than bulk voltage, we will have body effect. So what that is, it will give rise to change in the threshold voltage. We will see how it will be giving change in the threshold voltage. So if we, the point is, if channel is easy to form, the threshold voltage decreases. If forming the channel is difficult, threshold voltage increases. So for now, think about if bulk voltage is increased. So first VGG, we have here metal and one oxide layer and then semiconductor channel layer. So what happens is this metal layer and channel layer act as two plates of the capacitor. Here it metal, oxide and channel act as one capacitor. And other thing here, body as one plate and channel as one plate, and this depletion region as oxide act as oxide layer, and it will also act like capacitor. The point is, if we apply positive charge on one plate of the capacitor, the negative charge gets attracted on the opposite plate. So here, if VGG gate voltage increase, the channel gets formed easily. And if bulk voltage also increase, if positive voltage we apply, the channel also get easily formed. So what the point is, if bulk voltage increases, the channel is forming very easily. If now think about in terms of VSB. VSB means which is reverse of body to source VBS. So if VSB increases, VBS decreases. So if VBS decreases, forming channel gets difficult. So threshold voltage will increase. So what we come to the point is, if VSB increases, threshold voltage should also increase. This is the point. Now we will observe this in NGSpice. So here voltage sources I have defined as sorry first yeah, I have included the level 3 model file, and three voltage sources I have defined as VDD connected to drain and bulk, VGG connected between gate to bulk, and VSB connected from source to bulk. I have kept drain at 5 volt and I will plot ID versus BGS. So for that I will DC sweep the voltage source VGG, and similarly how we used for each loop, in the same way we will use here also, but instead of altering parameters like width or length, here we will alter the voltage source VSB. I will write the control block after defining this. So dot control, and for each variable name I will take as variable itself, and I will write as 0 volt, 1 volts, 2, 3, 4, 5. All right. Alter. Now what I have to alter is, I have to alter the voltage source VSB. So I'll write alter VSB. It is DC, right? So alter VSB DC. How we were defining voltage sources DC and its voltage, right? So its voltage I want as variable. So DC dollar variable. This is the syntax to define to alter the voltage sources. What is that? Alter the voltage source name and DC dollar name of the variable. So now I'll run this and I'll end. And I have to plot the things. So plot DC1 dot current through voltage source VDD hash branch and -1 sign. We know already why this is. Similarly, I'll write from 2 to remaining iterations. After writing this, now I will end the control block and I'll end the netlist. So what we did, first I wrote for user friendly what we are performing, and then I have included the model file. Then I have defined the voltage sources as given in diagram, VDD, VGG and VSB. And then I have wrote the MOSFET M1 given width and length. Then I have performed DC sweep. Then in control block, I have used 6 iterations, and then I have altered the voltage source VSB. The syntax is alter the voltage source name and DC dollar the variable name, and then yeah, then I have plotted the things. Yeah, that's it. Now we will save this and we will run. Yeah, yeah, we can see that here. First iteration, second iteration, third iteration, fourth, fifth, and sixth. Yeah, here what we are observing is if VSB is increasing, the threshold voltage VTH is increasing. So here it's clearly visible that as VSB is increasing, threshold voltage also increasing. All right, and that's the thing. Yeah, that's it for this lecture.